Simulation start. We get the result. Stop simulation. Then we start the second simulation. Assalamualaikum warahmatullahi wabarakatuh. So I am Muhammad Aizil Fikri Raslan. Proceed for the activity number 2 for lab 1A. So the connection of the circuit is like this, which is we have DC supply 10 volt, multimeter as emitter, and the value of R1 resistance. Also for the multimeter, which is voltage, and the grounding for the circuit. So for activity number 2, we set the value of R1, which is 100 ohm, and don't forget the internal resistance of emitter. Okay, so this we set emitter and set the value is 15.5 emitter resistance, and click OK. And the voltage, alright, okay, this is voltage value. Next, we just run the simulation by clicking this button. Okay, as we see, the connection is run in a good condition. So for the resistance R1, which is 100 ohm, we can see the current through the circuit by double clicking this multimeter. As we see, the current pass through the circuit is 86.58 milliamp. So how about the voltage across the circuit? Just double click this multimeter. Okay, can we see the value of voltage through the circuit is also 10 volt. Okay, next, how we can change the value of R1 for 150, 200 ohm, 300 ohm, also for 1 kilo ohm. Before that, we just stop the simulation. Okay, then we double click this. So we change the value for 150 ohm, and then click OK. Then we run again the simulation. Okay, so as we see, the value of current is changing, which is 60.423 milliamp for the resistance 150 ohm, but the value of voltage is remain the same as before, because the voltage is horizontally by the DC supply, so the value will not change. Okay, that's all from me for activity number 2, and don't forget to make others resistance, which is the value is 200, 300, also for 1 kilo ohm. Okay, thank you.
Let's we go to the simulation for activity 4. This is all the circuit that given in the lecture, and we just need to rearrange the circuit by arrange a true component ground, and the most important thing that we need to measure is current and voltmeter based on resistor that given in the lecture. So for the first resistor, we use 150 ohm, and let's we check the current from the emitter and the voltage from voltmeter. But first of all, we need to change the internal resistance for voltmeter. We're using 10k ohm. Okay, let's run the simulation first. Alright, and just simply click at the multimeter for emitter, and you get this value for the first resistor that we apply. And let's look at the voltmeter. Okay, we get 10 volt for this first simulate. Okay, next we change the resistor. Okay, for the next exercise 1A, is different from the previous exercise. For the first exercise, we need to measure DC connection, but for this exercise, we need to measure AC connection. Okay, so let's move to the activity 1. Okay, this is the circuit given for activity 1, and we need to find the current and voltage from this circuit by using multisim, of course. And this is all result that we get from multisim. Okay, this is the result for the 4 resistor given. This is the calculation to calculate the value. Okay, that's all. Let's we move to the simulation. Okay, this is activity 1, simulation. Okay, for AC connections. Okay. First of all, we just need to arrange this circuit, and arrange the component correctly. And next, we can simply get the value from this and next we can simply get the value by measure by put the value for resistor, the first resistor given, which is 210 ohm. Okay, let's rerun the simulation. Okay, for the first we get the current value 47.619 milliampere, and the voltage is 10 volt. So we just need to change the resistor. Okay, the next resistor is 390. Okay, and we run the simulation again. So this is the current value we get, which is 25.641 milliampere, and the voltage remains same, which is 10 volt. And next, we just do the same thing. We just need to change the resistor. For the next resistor, we use 470 ohm. Okay, we run as usual, and we got 21.276 milliampere current, and we got 10 volt for the voltage. Okay, lastly, the resistor given they need to calculate is 860. Okay, just simply run the simulation. We got 11.6 to 8 milliampere for the current, and yeah, the voltage is same, which is 10 volt.
Okay, next I go through for the activity number 2, lab B. Lab 1B, so can we see the supply is 50 volt RMS and the frequency is 50 Hz, which is the supply is AC current, and we set the multimeter as ammeter. Also for the R1, which is the value is 210 ohm, R2 390 ohm. Also for the grounding, and this for the voltmeter R1 and this for voltmeter for R2. So next we run the simulation by clicking this. So the simulation in a good condition, running properly. So how can we check the current for this circuit? Just double click this, and the value is 83.33 milliamp for current. How about the voltage across the resistor R1? Double click this voltmeter. The value is 17.499 volts. How about the voltage across the resistor R2? Double click this multimeter, and the value that we see is 32.499 volts. Okay, so that's all for activity 2 for lab 2B. So this activity also need to change the value of R1 and R2 by clicking this double click, and also for the R2 double click this and change the value of R2. Okay, that's all from me. Thank you.
The first simulation. Start. We got I1 and then I2. This is volt for the voltmeter, and then stop simulation. The second simulation. Second simulation start. This is I1 and then this is I2. This is the volt. Stop the simulation. The third simulation. Third simulation start. And then we got the I1 and then I2. Volt still the same. And then stop simulation. The last simulation. Last simulation start. We got I1, this is I1, this is I2, and this is the volt. Stop the simulation. Thanks